Hey guys, this is Professor Janacek, and I'm going to go over an example of implicit differentiation. Remember, implicit differentiation, again, is where we do not have to isolate y before we get started. We take the derivative of y, find dy dx within the equation. We also have to remember to always use the chain rule. So let's take a look at example 5 here. We want to find the equation of the line tangent to x squared plus xy minus y cubed equal to 7 at the point 3, 2. Now remember, in order to find the equation of a line, we will need to find the slope of the tangent line, and we'll need, of course, a point. Now we have the point 3, 2, but we will need the slope of the tangent line. The slope of the tangent line, of course, is the derivative. Well, actually, we can even give it a name. That's dy dx. So let's see about that. Since we have this equation, we know that if we take the derivative of that equation with respect to x, take the derivative of each side with respect to x, that should help us find the slope. So that gives us 2x. Remember, we do need to take the derivative of x with respect to x. That's the chain rule we're talking about. All right, the next piece, this middle piece here, that is x times y. X times y, that's a product. We will need to use our product rule. Product rule says we'll take the derivative of the first times the second plus the first times the derivative of the second. And then we will take the derivative of our last piece. Well, the derivative of negative y cubed is negative 3y squared, but chain rule says I then have to multiply by the derivative of y with respect to x, which is dy dx. On the right-hand side, not so bad. We're going to take the derivative of a constant. That is just 0. All right, so we can simplify all this just a little bit. Notice I don't need these parentheses anymore. Nothing to distribute there. Also, the dx's here, that's all just 1. And then also, I could, if I wanted to, go ahead and rewrite y prime for in place of dy dx. So let's do that. That might simplify things just a bit. So then we have 2x times 1, don't need to write that, plus 1 times y, that's just y, plus x times y prime minus 3y squared y prime is equal to 0. All right, not so bad. Now the idea is I want to go ahead and solve for that y prime. So that, let me go ahead and keep these two terms that have y prime. I'm going to go ahead and keep them on the left-hand side, but then these two terms that do not have a y prime will move over to the right-hand side. We will do that, of course, by subtracting them from each side of this equation. Right now, on the left-hand side, I do want to go ahead and factor out this y prime. That will allow me to isolate it. And then we can solve for y prime. Y prime is negative 2x minus y over x minus 3y squared. Of course, we've got this point 3, 2. Evaluating y prime, at that point, notice you could also write this notation to say that we're going to evaluate y prime at that point 3, 2. We get negative 2 times 3 minus 2 over 3 minus 3 times 2 squared. All right, let's see, what do we get? If we do all this multiplication, addition, subtraction, reducing the fraction, we end up with positive 8 over 9. Watch those negatives. I think those do reduce down, and we end up with a positive 8/9. All right. So we said we needed a slope, and that's exactly what we have. So now we need to, well, let's just make note that this is the slope of the tangent line at that point 3, 2. So now we need to find the equation of the line through that point with the slope 8 over 9. Well, how do we find the equation of a line? Well, remember that's y minus y1 is equal to m times x minus x1. That is the point slope equation. We will use 3 for x1, 2 for y1, and 8/9 for m. That gives us y minus 2 is equal to 8/9 times x minus 3. If you distribute the 8/9, add 2 to each side, we end up with y is equal to 8/9 x. Ooh, watch those positives and negatives. What does that give us? Combine those terms there in the back. You should end up with, oh, reduce the fraction as well. We get, what, minus 2/3. And there we go. That's the equation of our tangent line. Enjoy!